ready to just plug it in to low. This is, I don't like the order in which they present it. So once, I don't know, whatever. But anyway, here's the derivative. I'll try to do it the way it says there. The derivative of f times g minus f times the derivative of g over g squared. And then just a little bit of algebra to clean that up. 3x cubed plus 3x squared minus x cubed over x plus 1 squared. And then finally 2x cubed plus 3x squared over x plus 1 squared. Woohoo! Got the same answer. And we got it a heck of a lot faster. So on the exam, will you have to use the limit definition? Yes. There will be a problem or two where it says use the limit definition to determine the derivative of this function. Because it's summer, I will give you the limit definition so you don't have to have it rammed into your head. Normally I wouldn't do that, but I know there's so much stuff going on. What?
Huh?
He's admiring his hand.
It's a gorgeous hand. I do much with these hands. Good hand. Nice.
Your fingernails are way too short.
It's hard.
Oh. Well, what about that only gives you one hand. Oh, why is the other hand needs to be long for picking?
Symmetrical.
All right, fine. This one's kind of cool because it cleans up very interestingly. So there we go. There's a derivative. Again, let's change its name so that we're not confused by this f and g stuff here. And the top is always the f piece. So the f piece is x squared minus 3x. The derivative of the f piece with respect to x is exponent times the variable to the exponent minus 1 minus the multiplier times the exponent times the variable to the exponent minus 1. So that's 2x minus 3. And then the g piece is the bottom. So the g piece is x squared minus 2x plus 1. And the derivative of the g piece is exponent times the variable to the exponent minus 1 minus 2 times the exponent times the variable to the exponent minus 1. And the derivative of a constant is 0. So that'll be 2x minus 2. And now we're ready to just plug it in. And there's, I don't think I can even fit it on here, but we'll see. So the derivative of my function is the derivative of the f part times the g part, whoops, minus the f part times the derivative of the g part over the g part squared. Foil that, foil that. 4x x squared minus 4x minus 6x plus 6. There's no way I can do all that. Let's see, 2x cubed minus 2x squared minus 6x squared plus 6x. What have we got now? 4x squared minus 10x plus 6 minus 2x cubed plus 8x squared minus 6x. I told you this one cleaned up really nice, right? It does.
Isn't the top left, the first part supposed to be the x squared minus 2x plus 1 times the derivative of the top?
Okay, let's go with where you're talking about first.
The second,
Oh, there is a
Yeah.
mistake there, isn't there? Yeah, this is,
the first part, before the, like the derivative times the,
it's the derivative of the f times the,
Derivative of the g.
times the g.
Times the g.
Oh, God. Messed that up way back, way back. Let's just do it this way. There. Just skipped a step, trust me, that's the way it works, because I just did it there. Well, I didn't just do it there. So my derivative is 2x cubed minus 2x cubed. Yep, so those will go away. Oh, let's just distribute that across. There we go. And we've got minus 7x squared plus 8x squared. 8x minus 6x. I told you it cleaned up really nicely, right? Ha! Didn't notice that, did ya? So we can reduce that right there, and our derivative is x plus 3 over x minus 1 cubed. Now the question is, could we have made our lives a little easier? No. But that's why you have to do the algebra, because a lot of times they'll clean up very nicely and you'll be left with something not nearly as horrible as you thought you had. Woohoo! I lose my notes again. No, I didn't. Okay, so that's it for section 2.3. So have your section 2.3 homework done on Monday. Yes, sir.
Would it be possible to use the product rule if we switch the bottom half of the fraction to a negative power?
Yes, you can do that. So what he's saying is, let's do this. You don't have the chain rule yet, so no, you can't. But guess where you're gonna get today? The chain rule. Woohoo! So with the chain rule, you could do that way. Good introduction to the next section. I love those good segues. So could I find the derivative of that? Well, sure, because I could just multiply it out, and then I could, well, not actually multiply it out, just write it in expanded form. So I could say, well, here we go. And then I could either use the product rule, or I could FOIL it out and just use the simpler rules. Either way would be perfectly fine. And that'll work just great. However, what about same binomial expanded to the 10th power? Well, unless you can really remember Pascal's triangle or the binomial expansion theorem. Ew. So how are we going to deal with that? Well, how we're going to deal with that is called the chain rule. When we have a function embedded within another function, whoa, you remember composite functions? Composite. That doesn't look right. Composite. Must be. Composite functions. That's like, okay, I give you f, and I give you g, and I say find f composed with g. So that just means treat g like it's a variable in f. Okay, so I'm going to plug this mess into there, and that will be my composed function. 2 times 3x squared minus 9 plus 3. And then of course I probably want to algebraically clean it up and get 6x squared minus 15. I think. But there's a plus 3 on the end. I tried to do all the math in my head. Aha! And of course, the other thing to remember is g composed with f is typically not the same thing as f composed with g. They're very special functions if they are the same. So now we're going to treat f like it's a variable in g. 3 times 2x plus 3 squared minus 9. And I'm not expanding that one out. We're just saying that's the concept we're going for. Well, what we're going to do now is we're going to be decomposing functions. And decomposition of functions is hopefully fairly easy what we're looking for. So what we're really looking for is we're looking for something that looks like a function embedded in the function itself. Well, looks to me like that guy right there, 2x squared plus 4, that's a function, that's a parabola. Skinny, happy parabola with